Hello, welcome to my space presentation. Space Settlements by Chaya Alka-Fisher. Ever since the first spacecraft was launched, mankind has had a multitude of questions about space. Was there life on other planets? When can the ordinary person go up in space? What happens if an asteroid hits us? And most importantly, could we ever live in space? The answer is yes, we could eventually live in space, not on the moon or other planets, but in gigantic spacecrafts called space settlements. In fact, some people, including theoretical physicist and cosmologist Stephen Hawking, believe that it is humanity's only chance to survive. Here on Earth, we could easily be wiped out by nuclear or chemical warfare, or even an asteroid like the one that killed the dinosaurs millions of years ago. If space settlements could be built before such a disaster took place, the unaffected space settlements could provide aid to planet Earth. Why can't we colonize Mars or other planets? First of all, most planets are too hot, too cold, too far away, and have no solid surface. Second, the reason why we can't live on Mars is because there is much less gravity there than there is here on Earth. Children raised in a settlement in Mars wouldn't develop the proper muscles or bones needed to come back to Earth. 3. Mars is too far away from Earth to transport the materials needed for building the settlements. 4. Most places on Mars are in darkness half the time. Mars is also much farther from the sun than Earth, so it receives about half the solar power that is available at the Earth's orbit. Mars also has dust storms that interfere with solar power. The hottest place on Mars is colder than the coldest place on Earth. The moon is even colder at night, and it literally boils during the day. Why can't we colonize Mars or other planets? Continued. 6. Space colonization is, at its core, a real estate business. Real estate is determined by many things, including the view. While spacecrafts will have a beautiful view of the stars, a beautiful home planet Earth, and the other wonders such as asteroids, moons, and other planets, all the inhabitants of Mars will see is orange rock. Since an unprotected human can only survive outside of a settlement for a few seconds, bigger settlements are better. It won't be possible to build colonies on the moon or Mars much bigger than buildings on Earth. However, in orbit, everything is weightless, and that makes large-scale construction much easier. The moon and Mars combined have a surface area of roughly the size of Earth. As such, there's only so much room for growth, but there's no limit to the amount of spacecrafts we could launch. Why can't we colonize the moon or other planets? Continued. 9. Spacecrafts near Earth can service Earth's tourist, energy, and materials market, and Mars can't because Mars is too far away to trade with Earth. Space colonies will be very expensive to build. Supplying Earth with valuable goods and services will be critical for paying for colonization. For all of these reasons, orbiting spacecrafts will come first, and lunar and Martian colonization later, if ever. The only advantage Mars and the moon has over spacecrafts is that there are plenty of materials there. However, this advantage is eliminated by simply building the spacecrafts near asteroids. It may even be easier to mine asteroids for materials than Mars or the moon, as there is much less gravity. Space settlements, spacecrafts. This spacecraft would have to be airtight to hold a breathable atmosphere. Earth gets its gravity through rotating around the sun, so the spacecraft too must rotate around a moon or an asteroid or even Earth to provide gravity for its inhabitants. Enormous amounts of matter must cover the settlement to protect its inhabitants from radiation. On Earth, our atmosphere does this job, but each spacecraft will need about 5 tons of matter covering every square inch of the outside of the ship to protect space settlers from cosmic rays and solar flares. Each settlement will need to be an independent biosphere. This means that all oxygen, water, waste, and other materials must be recycled endlessly. If space settlements become a reality, ordinary people could live in colonies. Some groups might find this particularly attractive. For example, the handicapped could live in a special colony at 0-degree gravity, making wheelchairs and walkers unnecessary. Penal colonies could be created in orbit, as they should be fairly escape-proof. People who wish to experiment with very different social or political forms would have the opportunity. Eventually, most people in space settlements will be born there, and someday the space population might vastly exceed the population on Earth. The future. Early settlements can be expected to orbit the Earth. Later settlements will spread out across the solar system, taking advantage of the water in Jupiter's moons or the easily available materials of the asteroid belt. Eventually, the solar system will become too crowded, and some settlements will head for nearby stars. Interstellar travel seems impractical due to the long travel times. But what if you'd been living in space settlements for 50 generations? Would you really care if your spaceship was near a sun or in transit to a star near Jupiter? If energy and materials for the trip can be stored, a stable population can migrate to nearby stars. At the new star, local materials and energy can be used to build new settlements and resume population growth. Space tourism. The key to space tourism is finding an inexpensive way to transport people into space. In 2004, Burt Rutan's company, Scaled Composites, flew their privately developed rocket, Spaceship One, into space 3 times. They sold this technology to Virgin Galactic. Virgin Galactic has put $20 million into developing 5 larger vehicles to carry tourists into space. The cost is expected to be around $200,000 per flight. Burt Rutan's predictions. Within 5 years, 3,000 tourists will have been to space. Within 15 years, suborbital tourism will be affordable, and 50,000 people will have flown. Within 15 years, the first expensive orbital flights will have happened. Within 25 years, orbital tourism will be affordable. If these figures are accurate, it's reasonable to expect the first orbital colony to be built within about 50 years. Note that these numbers came out in 2004. The first hasn't happened yet, so it's possible this might not be entirely accurate. Advantages of space colonization. The key advantage of space settlements is the ability to build new land rather than take it from someone else. This allows a huge expansion of humanity without war or destruction of Earth's biosphere. Low Earth orbit settlements and eventually settlements near Jupiter and Saturn will have some of the most spectacular views in the solar system. Of course, all the settlements will have an unmatched view of the stars unhindered by clouds, air pollution, or bright city lights. On Earth, we all share a single biosphere. If one company pollutes the water, then everyone has to drink contaminated water. However, each spacecraft is a completely sealed biosphere and doesn't share atmosphere or water with other settlements or Earth. Therefore, if one settlement pollutes their water, no one else need drink it. Since the entire environment is man-made, you get to choose whatever you want. If you want lakefront property, build lakes. If you love sunsets, program sunset simulations into your very own weather system. Power and wealth. Those that colonize space will control vast lands, enormous amounts of electrical power, and nearly unlimited material resources. The societies that develop these resources will create immense wealth and wield power. Space settlement will be extraordinarily expensive because launch vehicles are difficult to manufacture and operate. For example, in 2004, it cost $30 million to send an individual into orbit for a short time. To enable large-scale space tourism by the middle class, this cost needs to be reduced to about $1,000 to $10,000. How? A radically different way of manufacturing technology. Like what? Molecular nanotechnology. This means building things out of diamond-like materials, placing each atom at a precise location. Diamond is 69 times stronger than titanium for the same weight and is much stiffer. If spacecrafts were made out of diamondoid materials rather than aluminum, they would be much lighter, allowing more payload. I hope you enjoyed learning about space settlements. My source for this presentation was settlement.arc.nasa.gov/basic/www.h.html.